think that my PowerPoint is not shown here. Okay. Okay. Hello everyone. Welcome to our second session on aerospace fluid mechanics. I remember that last session I taught you until continuity equation, and today we want to further simplify the continuity equation. But before going to that, I want to show you the Wright brothers airfoils and tell you some aerospace terminology. I will tell you about this. First, show you. Okay, this is the airfoil evolution. Last session, if you remember, over the board, I plotted for you the first airfoil used by Wright brothers. You see on the top left, it is the Wright brother airfoil. As I told last session, the airfoils create lift by their camber. Okay, let me plot something for you over the board. This is an airfoil. It is the cross section of the wing. Okay, so the wing of the airplane, if you cut the wing, and you will see something like this. It is the cross section of the wing. So, and this cross section has a mean line called camber line. And a line here, this region is called leading edge. This point is called trailing edge. Camber line is the mean line of the airfoil. Chord line is a horizontal line connecting leading edge to trailing edge. It is chord line. And this is the thickness of the airfoil. So airfoil has three main characteristics: camber line, which is the mean line; chord line, which is a line, horizontal line connecting the leading edge to trailing edge; and thickness. Thickness is the thickness of the airfoil. I want to tell you how the airfoil configuration came to the mind of the aerospace researchers. So first take a look at this cylinder. Okay, it is a cylinder. Flow approach this cylinder and go up and go down. What happens for the flow behind the cylinder? Yeah? What happens for the flow behind the cylinder? Yeah?
There's turbulence?
Yeah.
It detaches.
Detaches, yeah. Turbulence, I understand you want to say it is eddy, vertical. So it means that the flow, assume you are driving with a very high speed and you suddenly reach to a turn. If your speed is so high, you cannot follow the turn. You go this way, and the path goes on the left. It is for the flow. Flow goes with higher speed over this side, not very high speed, maybe a few meters per second. But this term is very severe for the flow. So the flow cannot turn. So the flow goes, oh, I want to go like here. I want to go straightly. But the flow doesn't follow the geometry. So here there are some vortices. There are different vortices pattern you may know from fluid mechanics, but the researchers, the fluid dynamists, went to the wind turbine, wind tunnels, and studied this cylinder. They thought, oh my God, the flow here is dead. It is like an artificial body that flow moves above the artificial body. This is just an artificial body that flow follow over it. So it is a dead body. It is not a real body, but these vortices acts like a body that flow move above and below them. So they told, in order to avoid these vortices, we shouldn't have a sharp silent, very sharp cylinder. We should have some turning point at the leading edge, and then make like this. If we make like this, the flow moves very smoothly over the body. Maybe I increase the okay? So airfoil came to the mind of the designer, of the fluid dynamist, of the researcher after studying the cylinder. Cylinder has a lot of artificial dead flow behind it. We should avoid this artificial dead flow. Why the vortices are bad? Can anyone tell why? Yeah?
Well, in terms of the airfoil, if it's at maximum angle of attack, that dead region acts as something that has to move with the airfoil, so that leads to stalling.
What does they increase?
It increases drag.
Drag force, yeah. They increases the drag force. You see, I want to pass, I have an airplane. My airplane, I am a person who doesn't know aerodynamics. I use a cylindrical wing. So when I want to move this wing with myself, assume my wing are cylinder. My hand is like a cylinder. When I want to move this cylinder with myself, there are a lot of vortex behind me. I should pay to energize these vortices. I should use a very heavy, very powerful engine, that this engine carry these vortices with me, because these vortices are attached to this cylinder. This cylinder moves in the sky. So these vortices also move. We should pay for their movement. So we should use more fuels to bring both my hand and the vortices behind my hand. This is the bad thing about the cylinder. Okay? So, and it is good for airfoil. So airfoil is something that is streamlined. There is no separation or very, very limited separation. Not a large amount of separation, just a very, very small region of separation. So separation or vortices are not good because they carry energy. We should pay for moving them. Remember the first generation of cars. The first generation of cars were very rectangular shaped, okay? Because on that time, there is no wind tunnel to test the cars. The people don't know if they make the car surface smooth, they have less drag, okay? For the car aerodynamic, we don't want lift for the cars by certain. And sometimes we want negative lift, okay? Especially if you have a racing car has very high speed. So if they lift, it is very dangerous. So we should use some spoilers that create downward lift. But for the cars, the aim is to reduce the drag force. So every car that is designed and goes to the market, first the people, the companies bring the car to a wind tunnel, test the car, and try to minimize the drag force. If you do a Google search, and I am certain there are Wikipedia pages that report the drag force of various cars during the years. And if you follow the trend, you will see that the drag force of the cars reduced during the years. I had a master student with whom we work on reducing and minimizing the drag force for the cars. Okay, so Wright brothers had the wind tunnel. They had a wind tunnel. If anyone went to the Aerospace Museum in Washington, was anyone there in Washington? Yeah, in Washington.
But only the top portion, not the Wright brothers.
Yeah, Wright brothers is in the first floor. I have visited their airplane, and I want to show you. On that time, it is their wind tunnel. They had a wind tunnel. In the wind tunnel, they tested different type of airfoils, and then they selected very thin airfoil. Why they selected very thin airfoil? Because on that time they used fabric for the wing, okay? And Wright brothers airplane, if you take a look here, it is their wind tunnel. Okay, it is their picture. Okay, it is the Wright brother airplane. The Wright brother has the tail in front. The tail in front. The wing, why does my mouse doesn't show here? Okay, the tail in front, the horizontal tail in front, the wing in the middle, and the engine on the back. So it is a very specific design that later was modified. Last semester, I had a course on Introduction to Flight. I discussed a lot about this, but as some of you are new, I try to discuss about the Wright brothers because it is the history how the flight was started. And I don't forget we are in the continuity equation. Just today it was better that last session I worked with this, but it is not so late. So Wright brothers put the engine, the propellers on the back in order to have their good view of their front, okay, their front. They have the tail in front because their wing was not able to produce enough lift. So they used two wings, not one wing, they have two wings. Their wings are not very large. So compare this. Did anyone watch the Airbus A300? Did you see? Okay. You see how big is the wing? I compare so small is the wing. So for the conventional, for the modern airplane, maybe I write here. For the conventional airplane, the wing gives positive lift, upward force. The tail gives negative lift. Okay, and where to put the weight? If I put weight here, weight has less arm. Okay, yeah, weight is here. Okay? Assume we don't have a tail. What happened to the nose of the airplane? Yeah? If we don't have a tail, what happened to the nose of the airplane? Yeah, nose down. The nose is down. Why? Because the lift of the wing has a moment here. So we need a negative force on the tail such that the moment on the nose of the airplane be approximately zero. Sigma m nose should be approximately zero. So L wing this is D wing, this is D lift, D weight, D tail. Okay? So, in conventional airplane, we need a tail with a negative lift that help the airplane to have a balance of moment at the nose. But Wright brothers has not enough lift of wing. They need extra lift from their tail. So they put their tail on the nose to have extra lift from the tail. Question: What component in Wright brother design create lots of drag? You? No. You?
That connect the two
Yeah,
layers.
the rod. What is bad about the rod?
There's cylinders pretty much.
There are cylinders. Yeah. You see, they have lot of cylinders. These are like a cylinder. And the vortex, there are a lot of vortex shedding behind these rods. So it is a very bad, but they require that because they didn't have any seat for themselves. They didn't have any, let's say, line wing that create enough lift. Pay attention. Lift, let me write here. Is lift coefficient multiplied by lift wing. So lift of the wing is a function of lift coefficient. Lift coefficient, which is a function of airfoil camber multiplied by dynamic pressure. It is Q infinity multiplied by area. Okay, it is the lift of the wing. Pay attention that this lift depends on the area. The higher the area of the wing, the higher is the lift. Wright brothers, if they want a higher air body, they need more rod, they have more drag, they had fabrication limitation, and many, many more. So for that, they use two wings. What is good for if they use two wings? What is doubled in the equation?
Yeah.
No.
Area.
SW. S is doubled. CL is the function of the camber of the airfoil. The camber is the same. So just the area is doubled. CL is the same, V is the same, rho is the same. Rho is also rho infinity. Compare the quality of the chalk that university buy and that I buy. Okay. So, Wright brothers, they use their airplane in this, they build their airplane in this way. And last semester I discussed about the success reason of the Wright brothers. Why they became able to make the first human flight, a flight with a human. The reason is not aerodynamic. Aerodynamic was known for a long time. Before the Wright brothers, there were gliders. Aerodynamic were known. Their success was due to knowing flight dynamics. Aerospace has 4 branches: structures, propulsion, aerodynamic, flight dynamics. They were able to control the airplane, and the control was done by 3 approaches. I have an airplane, okay? I have an airplane. I am moving happily in the sky. A gust downward comes here, and my airplane goes up. If I don't control, I will stall. I will go this way rather than straightly. I want to go straightly. But downward wing put my nose upward. I should be able to return back to my position. Airplanes should be controllable. They should be able to return to their position. So the Wright brothers used their horizontal tail to move down. Take a look at this equation. If something bring the nose up, take a look at my hand. If something bring the nose up, I cannot change with the weight. I cannot play with the weight. I may play with the lift of the wing or lift of the tail. The standard is that when there is an upward gust, you play with the lift of the tail such that it returns back to the downward direction. So I don't speak about, maybe I speak about the Wright brothers. Wright brothers I plot Wright brothers. weight, lift wing, lift tail. Right, brothers? I assumed lift of the wing and weight are acting on the same point, which is not very good correct because I have, yeah, it is correct. Because moment on the leading edge is 0. On the nose, it is nose. Sigma m nose is 0. Okay? It is the nose. These two balances. Now I have a gust. So, or not I have a, oh no, I want, let me show in this way, not sigma m around the nose, sigma m around this point. We have a positive here, so in this case, in this configuration, it is positive. I assume it is C over 4. All this length is C. All this length is C, the length of the airplane. C over 4, we have some pitch up around the C over 4. So to be in balance, the lift and weight shouldn't be on the same point. It is 1. Lift of the tail, it is this way. Lift of the wing. Wait. Does this work or no? Yes, this is good. I will explain in a second. Sigma m at C.4. C.4 is a portion, is a point in the airplane. One fourth of the length of the airplane from the nose. L tail multiply C over 4. Okay? L wing, it is done, it is clockwise. Oh, it is clockwise, it is counterclockwise, it is clockwise. So L wing should be behind the weight. This is minus. Please check me if I am right or no. This is clockwise. Let me plot here. This is clockwise, M tail. This is counterclockwise, M wing. This is clockwise, M, ML, and weight. So let me explain. Lift of the tail multiplied by 3/4 give a clockwise moment. Lift of the wing multiplied by d of the L minus c/4, the arm, gives a counterclockwise. Weight give a clockwise. So for the Wright brothers, weight center of mass should be slightly ahead of center of aerodynamic center. For them, it should be like this. Now consider it should be 0 originally. Yeah.
I'm just a little confused. How is the center of the weight in front of the wings when the engines are mounted behind the wings?
The engines are not because it doesn't matter that if the engine are behind them, necessarily the center of mass goes there because the propeller are there. The engine is distributed. You see the engine, the pistons? It is the piston, the gray ones. They are distributed over the wing. The engine is not on the back, just the propeller is on the back. Okay, you?
Yeah, does that mean that shouldn't it not be equal to 0 because you said that's
This configuration, it is not 0 for this configuration.
Oh, okay. But
Yeah, for
that
this
one-
one, it is 0.
you took a counterclockwise as negative?
Yeah.
Okay.
Any other point? Do you agree with this configuration? It is. You should know very well your statics or strength of material. Now, I want to ask you a question. I am the Wright brother. I am flying in the Wright Flyer 1, and suddenly a gust, an upward gust, is approaching my airplane. What should I do? Such that my nose return back to the horizontal. And this happened, gust. What should I do? Yeah? Yeah.
Be able to move your tail, the elevator, so you can
What should I create to balance this upward?
create more lift or drag
For more lift from where?
the tail.
If I create more lift, you see, this helps the lift of the tail. If I create more lift, I create more the first tail. So my balance is disturbed. Yeah?
Right, negative lift?
Yeah, I should reduce this lift such that the net of this plus this be the same as original L tail. Okay? For example, I had 100 L tail here. I have a gust which create 20 equivalent lift. So I should make it 80 from 100. Okay? So they should reduce the lift of the tail. So their tail is in the front. If the tail is on the back, it is fully different. Okay? You should understand this. The moment should be 0, around approximately. Okay? There is a tendency to have some negative moment. Okay? But at your level, we assume the moment should be 0. If the moment should be 0, take a look. A gust wants to bring it up. The lift of the tail also wants to bring it up because it is positive. So I should reduce the lift of the tail such that lift of the tail plus the lift of the due to the gust be the same as previous lift. So Wright brothers, in order to control their airplane, they used this tail. The tail, or is, take a look here at my hand, these are tail. If I want more lift from the tail, I turn my hand this way. I have more angle of attack. If I want negative lift, I make my hand in this way. I reduce the lift. If it is your airfoil, if you bring it up, you get more lift. If you bring it down, you get less lift. I will explain the lift later for you how this increase the lift, this decrease the lift. Originally I am here. If the airfoil is like this, more lift, like this, less lift. So I am Wright brother. I am moving with my airplane. I want to go to the right in this way. I want my nose goes to the right. I have a rudder, a moving vertical tail at the back. Okay? So assume I am here. It is my airplane. It is my rudder. Originally, I am here moving in the sky. Okay? Suddenly, I want to go to the right. I bring my rudder to the right. Take a look. Can you get up and come here? Can you push my second hand to the?
This hand?
Yeah.
Which way? This way?
Yeah. Like this, my left hand.
Okay.
Okay, you see? My nose turned to the right. So originally I am here. I turn my rudder to the right. Push it again.
The same
Yeah.
way?
My nose turned to the right. Thank you. I want to go to the left. I do the same with my rudder to the left. His hand was the air from the ambient air. Okay? I am here, ambient air push it, and my nose turn to the right. It is the work of the rudder. So you understand the rudder, you understand the tail, the nose tail, and the other thing, the flight is something in the sky, okay? The flight is something in the sky. Sometimes I want to bank like this. Okay, you are in the airplane, your airplane, very many times I was in the airplane arrived to an airport which is super busy. I fly from Greece to Istanbul in Turkey, and at the middle of the day, the Istanbul airport was super busy. The flight control on the air didn't permit our airplane to land. It told us start rotating over the city for a while until there is a free way for you to land it. Okay? On that case, the airplane is here, like here, wants to bang in this way. Okay? So if the airplane wants to has imbalanced lift, originally I have two wings. I am airplane. I have two wings. Originally, the lift on both of my wings is balanced. So I am in this way, like this. If my right hand has a higher lift, I go in this way. If my left hand has, I go in this way. So now I should explain you how to create lift. Can anyone take a photo of these such that later share with me? I put in the canvas. Thank you. Assume I have this airfoil. And this is the flow streamline for the airfoil. And now I have this airfoil. And this is the flow streamline over this airfoil. The first airfoil, assume I didn't plot well, is a symmetric, no camber. It is asymmetric. Okay? So, lift is created due to pressure imbalance between the lower surface and upper surface of the airfoil. If there is a pressure, higher pressure on the top, lower pressure on the top, higher pressure on the bottom, lower pressure on the top, the net force is done upward. So lift is this equation. Integral P lower minus P upper dx from 0 to C. This length is chord line is equal to C. This length. The length of the chord line is shown by C. Okay, lift is this equation. So if you want more lift, create higher pressure on the bottom, lower pressure on the top surface. Consider the first airfoil. The first airfoil is very symmetric. The flow doesn't have any priority to move faster on the top or move faster on the bottom. Here's the same. Okay, take a look at me. I am a fluid flow. I come here and then I divide. I see, oh, it is symmetric. So it takes me the same time to reach here, the same time to reach here. So, and I return back, and if I don't separate, I go back here and go, continue this way. So in this way, this geometry doesn't create any lift because the flow is, let's say, divided equally on the bottom and top side. But take a look at this one. Take a look at this one. Which streamline is lengthier? Which streamlines? The top one is lengthier or the top one is lengthier or bottom one? Yeah?
The top.
Top. So, and there is one rule. If a streamline arrive here and divide into the top and bottom, the top and bottom should reach at the same time here. Okay? So, now, take a look at me. I am not at the middle. I am here. I come, reach to this point. I should go from here to here and from here to here. I should reach at the same time here. Which point, which way I should move faster? This one or this one?
The top one.
This one, because it is lengthier. It is lengthier. Okay? It is the top surface. Okay? It is the top surface. Lengthier. I should move faster such that on the same time I reach to this point. As soon as I start running with one of you, I start from I have a, let's say, zigzag way, you have a straight way. I should move faster. And we told each other we will reach to the door point on the same time. So I should move faster. So the flow here should move faster than the flow here. If the flow moves faster, from Bernoulli's equation, the pressure drops more. So Let me plot here again. It is our cambered airfoil, very cambered airfoil. Take a look at the streamline. A streamline, oh my God, so lengthy way. Here, so easy way. On the top, a streamline should move faster. So from Bernoulli equation, P upper drop, P lower is higher. I have a positive lift. I have a good lift. Okay? If you want to have a good lift, you should have lower pressure on the top surface, higher pressure on the bottom surface. So, in this figure, in the Wright brothers, take a look at my hand. I want to bank left. I should have higher lift here and lower lift here. The way that modern airplane use, take a look here at the airfoil. The modern airplane, the rear of the airfoil is movable. So they move this region more down. It increased the curvature of the airfoil, and I told you lift coefficient is a function of airfoil camber. Camber is curvature. So lift, go up. It is for, I want bank in this way, for my right wing. For my left wing, I do like this. So aileron, these are ailerons at the rear of the wing. Wright brothers take a look at Wright modern airplane. Just change the camber of the rear. Wright brothers doesn't know this technology. They change, it is my hand first, they increase this, and take a look at my left hand, they make it like this. Lift here, go up, lift here, go down. The entire wing go here, go here, and go here to reduce the wing. Reduce, increase. Okay, it is the Wright brother technology. Okay, it is the story here. Okay, this semester with the AIAA group, we want to make some drone workshop. Yes, Trinity? When it is planned? In March or end of February. Okay, yeah. So nowadays, I told last semester to the student, I cannot build the Airbus A380. It is super expensive. It requires many countries' investment. But I can have a drone, a small airplane working. Last semester, I put everything in the class. This semester, I want to encourage you to join the clubs, AIAA club, Rocket Club, or other clubs, and do these extra activities in the clubs. And if you perform some extra activity in the clubs, you will get some credit, but it's not obligatory. It is, let's say, highly recommended. So I highly recommend you to work with the clubs. And this semester, the club, the AIAA club, will work on the drones, because drones are game changer. I remember maybe 5 years or even 6 years ago, I watched a video from a startup. The startup built a UAV or drone The drone is very small. The people can put it in their pocket or in their backpack, and then they open it and throw it away in the sky, and the drone can follow the guy, and the guy speaks with the drone. Drone, please take me a selfie. The drone takes a selfie from him or her, and then instantaneously send this photo to their mobile phone. So it is a long time ago I saw that, but I didn't see that this comes to the market. Nowadays, you should think, if you are interested in aerospace engineering, you should think about creating things like that, okay? Now I know that Russia uses Starlink. Starlink is developed by Elon Musk, but Russia uses Starlink on their, let's say, their drones that attack Ukraine. So you see, the technology is not changed. I cannot build an Airbus 380, but I can make a drone, I can make a startup, I can use AI for my drone such that my drone do something, some task that other people or other drones cannot. So you should think about these things if you are interested in aerospace. If you want to continue your education in aerospace, you should. The Wright brother is 100 years ago. UAV and drones are today technology. Now the USA also has a plan that the new generation of the fighter is accompanied by a lot of drones. So it is a, let's say it's a mission done by fighter and drone. So this is a fixed wing. The drones can be fixed wing like this. It is a fixed wing. What is similar with this drone and Wright brother? Yeah?
It has two wings.
Two wings, yeah, two wings. Why you think it requires two wings?
Is it small?
Yeah, and when you have two wings, yeah,
It has short wings.
yeah. It is a, you see, S of one wing is a small, but when you have two wings, you have two short. But if you have a very large wing, very wide wing, you cannot put it in your pocket, or you cannot hide it, but you make it biplane. So specifically, I put it here because you cannot see a conventional biplane airplane. But in the UAVs, in the MAV, it is MAV, micro air vehicle. In MAV, you can see biplane. Oh, it is a very nice. Why it is very nice? Why it is very attractive? What are these? What are these? Solar panels. Solar panels. When I was working elsewhere, I had two bachelor students for their final thesis. They built a fixed wing airplane. In the over the wing, we put the solar panels. And you cannot use the same solar panel that you put on the roof of your home because they are super heavy for the airplane. So we order very, very lightweight solar panels and put these solar panels over the wing of our airplane. So another idea can be a drone with solar panel such that it increases the endurance, the time that airplane can fly in the sky. And this is the rotorcraft or drone that is used to carry the baggage. Okay, so in US, is there a city that, for example, Amazon or FedEx use the drones to deliver the packages? I don't think so, but maybe in future, maybe in 10 years. 10 years later, because you see the AI is expanding. So with the AI, you can have a CPU or a memory for the drone, and the drone is controlled and bring the package to the destination. So it is another idea. So these are the new ideas. As an aerospace engineer, aerospace engineer, we should be creative. The course aim is not to tell you the story, his story. It is not a history. The course aims to make you creative, okay? Make you creative for new design. Okay, you see this is another one. For example, in a restaurant, it can bring the some liquid for a person or someone else. Okay, and this is the forces of the airplane that you know. I discussed about this with you. And this is the 3-view representation of aircraft. So you have a course on design of mechanical engineering. In the aerospace engineering, when you design an airplane, the designer should give 3-view representation of the airplane. So it is the Boeing 767-200. It is the front, top, side view, front, top, side view of the airplane. It is very informative. The front view tell us, take a look at my hand, I am the front view. My hand is not like this. My hand is like this. I have dihedral angle. So the wings are not attached to the airplane like this. The wings are attached like this with some angle. This is used for the stability of the airplane. It is not the concept of this course. The wings, the side view. The wings are not, I am the side view. The wings are not like this. The wings like this. They had sweep angle. So dihedral, sweep angle. What does sweep mean? Sweep reduces the Mach drag divergence. Maybe later we discuss it. You see the wings are not rectangle. Wright brother were rectangle, but this is not rectangle. The chord here at the tip, it is tip, is much, much smaller than the chord on the root. On the root is the place that the wing is fixed to the airplane. At the root, the wing has a higher length. At the tip, the wing has a less length. Why? Because if you plot the lift force it is the airplane. If you plot the lift force of the airplane, it is the lift distribution. The lift is high at the root. The lift is high at the root. The lift is minimum or vanishing at the tip. So it is useless to use a rectangular wing because at the tip we don't have a lot of lift that will require a large structure. Okay? So when you don't have a lift, reduce the area. When you have a lift at the high lift at the root, increase the area. Because the structure should sustain the lift. Because the lift is something going up. Okay? The structure, if it is not strong enough, the structure will damage. The Wright brothers use a very thin airfoil. Because they don't have a very, let's say, lengthy wing. But if you use a lengthy wing, you require very strong body. Okay, I discussed about this. Okay, I skip this. I skip this because this is control, flight control. Okay, aerospace terminology. Let's give you a very, very rapid terminology of the aerospace. Empty weight, what the aircraft or a spacecraft weight when it is nominally empty. Okay, no crew, no fuel, nothing. So you are a company, you make an airplane. You tell me I am a rich person, I come knock at your door, I want to buy a personal airplane. What is the empty weight of the airplane? You give me a catalog. In the catalog, you tell me the empty weight of the airplane. Fuel weight that required to do mission plus required reserves. I take a flight from, for example, from Boston to New York. The airplane, who designed the airplane fueling shouldn't put just fuel for this distance, Boston to New York. They should consider if the New York airport is closed due to bad weather, due to emergency or something, I should land elsewhere or I should return back to my home city. Okay? I should have enough fuel for a second or reserve destination. So when the people put fuel in the airplane, they put fuel for the destination plus reserve destination. So for example, when the pilot do international flight, they should know where to land if there is a emergency, if there is something bad in the weather is very cold, like last week or last 2 weeks. Here the weather was very cold. Maybe they cannot take land in the Boston. So they should have alternative destination, fuel for alternative destination. And one point, I am a pilot, and then I take off airplane from Boston. I take off airplane, I am in the sky of Boston, and I see, oh my God, airplane has some damages. I should land again in Boston. I cannot land with the same weight that I take off, okay? Because I have lot of fuel. Airplane, the weight of the airplane, maybe 30% of the weight can be fuel, okay? The airplane fly from Boston to Orlando, and assume how much the weight is reduced when you reach to the Orlando. So if you are in the Boston and then want to land again in Boston, you cannot land. You should rotate around the Boston, spray some of your fuel, or if your airplane is able to land, you can land. But most cases you need to spray, eject out some of your fuel and then land it. Crew weight, weight of crew and associated equipment, parachute, oxygen, etc. Because why crew weight is important? Because when you sell an airplane to a company, the company crew weight, if it is high, it is not good for the company because they want passenger, okay? They want payload. They don't want crew. The last generation of airplane, maybe 50, 60, 70 years ago, they have pilot, co-pilot, and flight engineer. with the advent of the computer, flight engineer was removed, and it is in the benefit of the, let's say, benefit of the airline companies. Payload weight, or P-L, weight the aircraft was designed to carry passenger weight, baggage for aircraft. Pay attention. Payload weight change during the year. Okay? Winter is a good time for the airplane companies. Why? Take a look here. Rho. When the weather is cold, rho is high. Okay? Rho is high. So lift is high. You can carry more people in the sky. If we are in the winter and you are in Florida or Texas with a temperature of 100 Fahrenheit, this rho is very low. That low is low. So your lift is low. You cannot carry as many people as in the winter or as in the Canada compared to the Orlando. So what should you do? You should reduce the number of, you cannot say, oh, I have 100 seats free and I can sell them. No, you cannot. Or you cannot carry all the baggages. Some of the baggages you cannot, if the passenger have a lot of overweight baggages, you cannot carry them. So payload weight is season dependent, not a lot, by maximum 10%, 5%, it is depends. Gross weight, the nominal weight for a standard mission before the aircraft takeoff. So gross weight is the crew weight plus payload weight plus fuel weight plus empty weight. It is the gross weight. So when you buy an airplane from a company, it gives you all these details, especially for lightweight airplane, it should be very important. So these are some general information, and these are some aerodynamic and propulsion information. Wing loading. Wing loading is the aircraft weight divided by wing area. WL is W over S wing. Wing loading, W over S wing. Power loading, aircraft weight over power of the airplane. Aspect ratio, okay. Take a look at this wing. This is called B. This is C root, chord of the root. This is called C tip. Aspect ratio is B squared over S. It is some wing. This parameter, aspect ratio, appears a lot in our equation that we later introduce to you. Later, we will go to the sum. The higher the aspect ratio, the higher lift. So if you make a glider, you should have very, very high aspect ratio. You have a very lengthy wing. If the wing is rectangle, I plot here. S is equal BC, so aspect ratio is equal B over C for the rectangular wing. taper ratio. I write here, sorry, it is mixed. Taper ratio, it is C root C tip. CR, take a look here, CR divided by CT. It is the taper ratio. What is the taper ratio for a rectangular wing? 1. For a non-rectangular wing, it should be greater than 1. A specific fuel consumption, fuel weight over power multiplied by R, empty weight fraction, empty weight divided by gross weight, payload fraction, payload weight divided by gross weight. Thrust, we skip thrust, lift and drag. Okay, lift. As I wrote for you here, lift is due to pressure force, act normal to the aircraft, so pressure, the imbalance of pressure create lift. The imbalance of the viscous forces can create the drag. Viscous forces can create drag. As you see, there are here, boundary layer can create some. Pay attention. Airfoil drag is mostly due to viscosity. Cylinder drag, I clean here. Cylinder drag is mostly due to the pressure imbalance on the left and right. Just as the last equation here, it is the cylinder. Vortices here. So drag is P left minus P right. So cylinder, the drag of the cylinder is mostly pressure drag. The drag of the airfoil is mostly viscous drag. Okay, thank you. We will continue our discussion on Thursday. Thank you.